On August 28th, Earth's shadow will swallow almost the entire face of the full moon. At maximum eclipse, only a narrow, brilliant edge will remain outside the darkest shadow. The partial phase will unfold slowly for approximately 3 hours and 18 minutes.
Greatest eclipse arrives near 04:13 UTC, though your local date and time may differ.
The event reaches the Americas, Europe, Africa, the Eastern Pacific, and parts of Western Asia.
It may resemble a blood moon, but technically the eclipse never becomes total.
Unlike a solar eclipse, every phase is completely safe to watch with unaided eyes. This is the deep partial lunar eclipse of August 2026, the night the moon almost disappears. A lunar eclipse can occur only when the moon is full.
The Sun, Earth, and Moon must align, with Earth positioned directly between the other two.
Earth then casts a long cone of shadow outward into space beyond the night side. That shadow contains a pale outer penumbra and a much darker inner umbra. Entering the penumbra first, the moon dims so gently that most observers notice nothing. The spectacle becomes obvious when the moon's edge finally enters Earth's umbra. A dark, curved bite grows steadily across familiar craters and ancient lunar plains. At maximum, the eclipse reaches an umbral magnitude of approximately 0.93. That number measures the fraction of the moon's diameter immersed in the umbra. It does not directly describe surface area, brightness, redness, or cloud conditions. The moon passes slightly away from the shadow's center, preventing complete immersion and totality. After maximum, orbital motion carries the moon outward, and the dark bite slowly retreats. Inside the umbra, Earth's solid body blocks every direct ray from the sun. Yet Earth's atmosphere bends a small amount of filtered sunlight into the shadow. Molecules scatter shorter blue and violet wavelengths more efficiently than longer red wavelengths. The remaining orange and red light continues through the atmosphere toward the eclipsed moon.
It is as though every sunrise and sunset on Earth is projected onto the lunar surface.
Clouds, volcanic particles, dust, and atmospheric conditions can change the final color and brightness. The exposed lunar edge remains extremely bright, making the shadowed region appear darker by contrast. Cameras may reveal subtle red-orange detail that human eyes struggle to separate from the glare. The moon produces no visible light itself. It normally reflects sunlight toward Earth. During an eclipse, the changing colors simply reveal which paths sunlight can still follow. At the moon's distance, Earth's umbral shadow remains much wider than the moon. Brightness still varies across that shadow because atmospheric refraction is uneven around our planet.
The faint penumbral phase begins near 01 versus 24 UTC on August 28.
The clearly visible partial eclipse begins around 0234 UTC as the moon enters the umbra.
Earth's shadow reaches its deepest point across the moon near 0413 UTC. The partial phase ends around 0552 UTC, approximately 3 hours after it began.
The final penumbral shading fades near 0702 UTC, ending the complete event.
For many American locations, Observing begins late on August 27th and continues past midnight. Large parts of the Americas can follow the moon through the most dramatic partial stages. Across Western Europe and Africa, the eclipse unfolds before dawn as the moon approaches moonset. Some European observers will lose the moon below the horizon before every phase finishes. Buildings, hills, trees, or mountains can therefore hide a low moon near the western horizon. Parts of Western Asia may catch earlier phases, while morning twilight becomes progressively brighter. Clear weather matters, but no narrow path of totality limits who can participate. Check an official local eclipse calculator, because universal UTC times require conversion for every location. 16 days earlier, the August 12th total solar eclipse occurs during a new moon. By August 28th, the moon reaches full phase and enters Earth's shadow. Both events belong to the same eclipse season, a temporary window of favorable alignment. An eclipse season lasts roughly 35 days, while the sun remains near a lunar orbital node.
Nodes are the two places where the moon's tilted orbit crosses Earth's orbital plane.
The lunar orbit tilts about 5 degrees, usually carrying the moon above or below alignment.
Without that tilt, solar and lunar eclipses would occur during almost every lunar month.
During a solar eclipse, the moon's small shadow races across a narrow region of Earth. During a lunar eclipse, Earth's much larger shadow falls across the moon instead. Anyone on Earth's night side with the moon above the horizon may potentially see it. This broad visibility makes lunar eclipses easier to share across continents than solar totality. More than 2,000 years ago, Earth's curved eclipse shadow offered evidence of a spherical planet. Aristotle noted that the shadow remained round, whether the eclipsed moon appeared high or low. Only a sphere consistently casts a circular shadow when illuminated from different directions. Modern calculations now predict each contact, visibility region, duration, and shadow geometry years ahead.
The August event belongs to lunar Saros 138, a repeating family of related eclipses.
A Saros cycle lasts approximately 18 years and 11 days before similar geometry returns. Earth rotates during the additional fraction of a day, shifting the next eclipse's visibility westward. Begin your own observation by checking when the moon enters the umbra from your location.
Choose an open site with a clear western horizon if the moon will be setting.
Lunar eclipses are safe throughout. Ordinary sunglasses and solar eclipse glasses are unnecessary.
Binoculars can enhance color and crater detail, but your unaided eyes are completely sufficient.
A small telescope reveals Earth's shadow advancing across individual craters and dark lunar maria. Arrive before partial eclipse begins, so the ordinary full moon provides a visual comparison.
Look again every 10 or 15 minutes, because the shadow changes slowly rather than suddenly.
The umbral edge appears slightly soft because Earth's atmosphere and shadow geometry blur the boundary. Near maximum, compare the brilliant remaining crescent with the subdued reddish surface inside the umbra. For photography, stabilize a phone or camera on a tripod before the eclipse begins. Phones render the moon small, so use genuine optical magnification instead of excessive digital zoom. A telephoto lens can reveal craters, color gradients, and the precise curve of Earth's shadow.
Manual exposure helps prevent the bright, uneclipsed crescent from becoming a featureless white patch.
Capture several exposure levels, because the bright and shadowed regions differ enormously in intensity.
An interval timer can record the moon's transformation consistently while you continue observing.
Combining carefully timed frames later can show the eclipse sequence in one honest composite. If the moon is low, a distant landscape can add scale, location, and atmosphere. Avoid unsafe roads, unstable rooftops, private property, and locations where darkness hides hazards. Remember to stop adjusting equipment and experience maximum eclipse directly with your own eyes.
A lunar eclipse also creates a rapid cooling experiment across the airless lunar surface.
NASA's solar-powered Lunar Reconnaissance Orbiter conserves energy when Earth blocks sunlight during eclipses.
Most instruments shut down, while the Diviner radiometer can monitor changing lunar temperatures.
Different rock sizes cool at different rates when direct sunlight suddenly disappears. Scientists use those temperature changes to estimate surface rock size, density, and physical properties.
After this partial eclipse, the next total lunar eclipse arrives on December 31st, 2028.
For one August night, Earth's ancient shadow transforms our familiar neighbor into an unfamiliar world.
Subscribe to Sky Through Time, where every shadow reveals another chapter of the universe.